The topic is compound inequalities. The first objective in this topic is finding the intersection of two sets. So when we talk about intersection of sets, we're using the keyword and. The solution set of a compound inequality formed with and is the intersection of the solution sets of the two inequalities. And intersection means overlap. So the intersection of two sets A and B is the set of all elements common to both sets. A intersect B is denoted by A upside down U B. So that upside down U is the symbol for intersection. And that just means common to both. It means overlap. It means and. So if it's in A and B, it is in the intersection, the overlap of A and B. So an example, let's find the intersection of the sets 2, 4, 6, 8 and 3, 4, 5, 6. The intersection is the overlap. So what appears in both? 2 is not in both. 4 is in both. 6 is in both. 8 is not in both. And we only have to do that to one set, because if we didn't come across, for instance, a 3 or a 5, that means it's not in both sets. So the only elements in common to both were 4 and 6. So the intersection is the set containing 4, 6. Objective 2 in this topic, solving compound inequalities containing the word and. Example, solve and graph the solution for x plus 4 greater than 0 and 4x greater than 0. So we have to solve both inequalities separately. That's the first step. So x plus 4 is greater than 0. Subtract 4 from both sides. We get x is greater than negative 4. That graph looks like this. And 4x is greater than 0. Well, divide both sides by 4. We get x is greater than 0. That graph looks like this. Now that we have both graphs, we know an and statement is the overlap. It's the intersection. So where do the graphs intersect? Where do they overlap? Well, they overlap just from 0 off to the right. So that overlap graph with interval notation 0 to infinity is the answer to the and statement. If we have something in this format, in the between format, 4 times the quantity 5 minus x is between 0 and 8, including 0, but not including 8. That's the same as an and statement. First, imagine that the less than 8 wasn't there. That's one inequality. Then instead, the less than 8 is there, but the 0 less than or equal to isn't there. That would be the other inequality. And means find the overlap. This already is betweenness. This already sets us up to be an overlap. Something in this form is the same as an and statement. So first we'll use the distributive property to distribute the 4 in the center through the 5 minus x. 4 times 5 is 20. Positive 4 times negative x is negative 4x. And now, just like with equations, whatever we do on one side, we do to the other, just like inequalities, whatever we do on one side, we do to the other. Here, whatever we do in the middle, we do in every part. So let's get rid of adding positive 20 by subtracting 20. Getting rid of the plus 20, the positive 20, by subtracting 20 from every part, from all the way on the left, from all the way on the right, and from the center. 0 minus 20 is negative 20. The 20 minus 20 cancel each other out in the center, leaving us with minus 4x. And then 8 minus 20 is negative 12 for the right part. Finally, to get the x by itself in the middle, in the betweenness, we need to undo multiplying by negative 4. That means that we divide each part by negative 4. However, remember that the sign direction changes when you divide by a number less than 0, when you divide by a negative. So when we divide each part by negative 4, suddenly this becomes negative 20 divided by negative 4 is positive 5. Negative 4x divided by negative 4 is x. And negative 12 divided by negative 4 is positive 3. The signs have changed. They now have greater thans. Previously, I said that wasn't allowed. We can't write betweenness that way. But notice what's all the way on the left. It's a 5. Notice what's all the way on the right is a 3. This is not left to right on the number line. 5 is not on the left of 3. So let's swing the whole thing around. This is actually the same as x is between 3 and 5. In other words, the overlap of x is greater than 3 and x is less than or equal to 5. If we're careful, find the 5. That's a square bracket. Find the 3. That's a parenthesis. And x was between, so shade in between. Now, if this was something like 3 is greater than x is greater than 5, there wouldn't be any solution there. But here, if we swing the whole thing around, write a 3 all the way on the left so that the little point is still with the 3, this is the same as 3 is less than x is less than or equal to 5. Now, some people might read this wrong and think that this says 2 is less than 4 minus x is less than 7. And that makes no sense. So if you're reading it that way, hopefully you're very confused because that means nothing. What this is actually saying is that the 4 minus x is between 2 and 7. So let's solve this the same way. Rewrite the problem. We want to get that x by itself in the middle, which means we need to get that minus x by itself in the middle, which means we need to subtract 4 to get rid of the positive 4. Whatever we do in the middle, we have to do on every side, so subtract 4 everywhere. 2 minus 4 is negative 2. 4 minus x minus 4, the 4 minus 4 cancel away, leaving us with minus x in the center. And then on the right, 7 minus 4 is 3. That means negative x is between negative 2 and 3. But we are interested in x. So we either have to multiply by a negative or divide by a negative, or a negative 1. This gives us negative 2 divided by negative 1 is positive 2. Negative x divided by negative 1 is positive x. 3 divided by negative 1 is negative 3. And the signs have changed from less thans to greater thans because of the dividing by the negative. We have betweenness written with greater thans, so we have to check and make sure it makes sense. We have the 2 all the way on the left. We have the -3 all the way on the right. That is not number line order. So if we flip it around, keeping the point towards the -3 and the point towards the x, we would have -3 is less than or equal to x is less than 2. Sorry, not less than or equal, just plain old less than. -3 is less than x is less than 2, and that is okay. Because when we graph it on the number line, the -3 falls to the left of 2. So we do have betweenness. -3 is less than the shading is less than 2. And this is the overlap between x is greater than -3 and x is 2. Sorry, x is less than 2. Because the -3 would go to the right forever, the 2 would go to the left forever, and where they overlap is just between the two values. The third objective in this topic is finding the union of two sets. So as opposed to the intersection, the union is either or. We take them both together. The solution set of a compound inequality formed with or is the union of the individual solution sets. So the union is both together. It's denoted by A union B, which is that U symbol, not an upside down U. The upside down U is intersection, that's overlap. Union means both. So let's find the union of 2, 4, 6, 8 and 3, 4, 5, 6. If it's in 1, it's in the union. So 2 makes it in, 4 makes it in, 6 makes it in, 8 makes it in, 3 makes it in, 4 was already in, 5 makes it in, 6 was already in. So what are we left with? 2, 3, 4, 5, 6, 8. If it appears once in either or, it makes it into the union. And union is an or statement. Objective 4 in this topic is solving compound inequalities containing or. So 5 times the quantity x minus 1 is greater than or equal to -5, or 5 minus x is less than 11. We have to solve them both individually first. So taking the first inequality, rewriting it, we would start by distributing the 5. 5 times x, 5 times -1, 5x minus 5. Then we want to get the x by itself, which means we need to get the 5x by itself. So get rid of -5 with +5 on both sides. That actually cancels away the -5 on both sides, leaving us with 5x is greater than or equal to 0. Get rid of multiplying by 5 with dividing by 5. 0 divided by 5 is 0. So x is greater than or equal to 0. That graph looks like this. Now taking a look at the other side, or 5 minus x is less than 11. Well, subtract 5 from both sides, gives us -x is less than 6. Divide both sides by -1, and dividing by a negative flips the sign. X is greater than -6. That one looks like this. An or is not an and. If this was and, it'd be the overlap like before. Or means both of them taken together. So if we look at both of them and take them together, then the second one, the one that includes more information, it includes all of 0 on, but it also has extra, would be both taken together. Not the overlap. The overlap would be the smaller. Both taken together is the larger. So -6 to infinity. Not including that -6, so a parenthesis there. That's both together. Okay, so I'm not drawing the MasterCard logo. I am drawing two sets, a set A and a set B. And notice they have an overlap here. By the way, whenever we draw circles and look how they overlap to represent sets, this is called a Venn diagram. So we have this Venn diagram here of sets A and B. And this part here, where A and B overlap, this is called the intersection of A and B. The symbol for the intersection is an upside down capital U. When we see the intersection of A and B, what this means is, where do the two sets overlap? What are the elements in common? So let's say A is the set 1, 2, 3. B is the set 1, 3, 5. What is the intersection of these two sets? In other words, what is the set A intersection B? What elements are in both? 1 is in both, and 3 is in both. So the intersection of sets A and B would be the set 1, 3. Because this set contains every element that's common to both A and B. Intersection is one type of thing. I don't want to say this other thing is the opposite, because it's not exactly the opposite. If it was the opposite, it wouldn't include the intersection. Next, we're going to look at the union. And the union is an actual capital U looking thing. So it is the upside down version of the intersection symbol. Union, capital U, just like the U symbol. Intersection's the other one, that's the upside down U. Union, Just means join together. So the union of A and B would be all of A mixed with all of B. So here, if A is 1, 2, 3, and B is 1, 3, 5, A union B is going to be the set 1, 2, 3, 5. Every element from A and every element from B makes it in to the final union set. So let's take a look at some larger sets. These were just 3 elements apiece. Let's say we have set A 1, 3, 5, 7, 9, 11, and set B 1, 2, 5, 7, 12. We're going to look for A intersection B, and we're going to look for A union B. The intersection, where they intersect, where they overlap, elements common to both sets. 1 is in both, not 2, not 3. 5 is in both. 7 is in both, not 9, not 11, not 12. So that's it. The intersection is the set 1, 5, 7. The union. Union is everything. If it's in A, it's in there. If it's in B, it's in there. So 1, 2, 3, 5, 7, 9, 11, 12. Every element from A or B makes it in. In fact, what did I say here? Every element from A or B makes it in. What word would we use for making it into here? It makes it in if it is in A and B. So an intersection is an and statement and vice versa. When we have an and statement, that means the overlap. When we have an or statement, that is the union. That's both brought in. So have another 20 minutes or so. If you need a break, take a break. We're going to expand this idea. And instead of sets that are listed out, we're going to have set builder notation. So we're going to let C be the set of all X such that X is less than 4. We're going to have D be the set of all X such that X is less than or equal to -2. We are going to look for both C intersection D, and we are going to look for C union D, both of them. Well, let's go ahead and look at the graph. Put that in a little bit better spot. I'll just put it here for now. Deal with these when we get to it. Up top, I'm going to graph C, and below, I'm going to graph D. For that, we're going to need -2, and we're going to need +4. C is x less than 4. So a less than would look like that with a parenthesis, and we're shading the things less than 4. Less than or equal to -2 would be a square bracket, but we're still going to the left because we're shading the things less than -2. When x is on the left, it actually shows us, it points which direction to shade to. So which of these is going to be easiest? Well, they're both pretty easy. The intersection is the overlap. Where do they overlap? I'm going to do this one in green. They overlap right here. From -2 to infinity. So x, let's keep it an interval notation. -infinity to -2. That's going to be C intersection D. Or x less than or equal to -2. Or the set of all x such that x is less than or equal to -2. Or in this case, because we have a special name for this already, C intersection D could actually just be considered D. C union D, that would be both together. I'm going to circle this in red. Both together, that's all of it. And this right here, D, that's already a part of C. So C itself, x less than 4, or -infinity to 4, but not including the 4, would be equal to C union D here. Let's do another. If you've got it already, that's great. These next examples, make sure you still have it. If you don't have it yet, or if you're a little shaky, these next examples are really going to clear things up, I think. We have set A. Set A is going to be the set of all x such that x is greater than or equal to 3. We have set B. Set B is going to be the set of all x such that x is greater than -1. On a number line, we would need -1, we would need 3. I'm going to go ahead and I'm going to graph A. A is x is greater than or equal to 3. I'm going to use red for B, greater than -1, parenthesis there. The overlap. The overlap is the intersection. Where does it overlap? Right here. From 3, including 3, to infinity. The intersection is all of it. This piece is included here, so all of it is just the same as the red one. A union B is just going to be from -1 to infinity. The intersection is the overlap, where it overlaps. The union is everything from both jammed together. New sets. A is going to be the set of all x such that x is greater than 0. B is going to be the set of all x such that x is less than or equal to -3. So what do I need on my number line to graph? I'm going to need 0, and I'm going to need -3. I'm going to go ahead and graph A. A is greater than or equal, or sorry, just greater than 0, not or equal to. So parenthesis, not a square bracket. B, that's going to be less than or equal to -3. Less than or equal to. Notice I didn't go below because there's not going to be an overlap here. No overlap means that there is no intersection. The intersection A union B is the empty set. A intersection B is the empty set. What about A union B? Well, we have this piece. We have the -infinity to -3 piece. But we also have this piece. And what we're going to do, I'm going to go ahead and write it down here so I have enough room. A union B is we're going to take the first piece and we're going to take the second piece and we're going to join them with the union sign. And this is another way of saying x is less than or equal to -3, or x is greater than 0. Because a union is an or statement. It makes it in if it's in this one or this one. They both come in. For an and statement, it would only be if it's in this one and this one. The two new hottest clubs are Club Union and Club Intersection. Now, the thing that makes these clubs fancy is that there's not just one list at the door, there are 2 lists at the door. And each club has its own rules. To get into Club Union, you must be on list 1 or list 2. If you're on list 1 or list 2, you get in at Club Union. Club Intersection is a lot more
restrictive. Okay, it doesn't let as many people in as club union. Club intersection, you get in if you are on list 1 and list 2. So 2 lists at the door. Club union, to get through the door, you just need to be on one list or the other. But to get into club intersection, you need to be on both lists. You need to be on list 1 and list 2. That's what union and intersection are. They're just like these exclusive clubs, and they have the exact same rules. For a union, you take them in if they're in one or the other. For the intersection, they have to be in both, first and second. Okay, we have time for some more examples. Let's take a look at the resulting set of negative infinity to 4, parentheses on both, intersection, square bracket 1 to infinity. So what I would do, just like before, we're going to go ahead and look at both of these. The interval from negative infinity to 4, we're going to need 4, 4. And we're going to need 1 for the other one. There is negative infinity to 4. And here is 1 to infinity. The intersection means the overlap. It has to be on both graphs to make it in club intersection, to get in this final answer. So where is the overlap? It overlaps here, with a square bracket on the left and a parenthesis on the right between 1 and 4. What about the union? Well, if we look at the same two graphs, and this time we want the union, then to make it into the final graph, it either has to be on one or the other. And between one and the other here, everything is covered. The answer here, all real numbers. Negative infinity to positive infinity. We saw that something like x greater than 4 which could be graphed as this on a number line with an open circle, or a parenthesis with everything to the right of 4, everything greater than 4 shaded, because the shading is the variable, and everything to the right of 4 would be the variable being greater than 4 to the right of on the number line. We also learned that if we had x less than or equal to -2, that would be either the filled in circle point or a square bracket with everything to the left being shaded, everything less than. And now these are both on the same number line. We saw in order to actually join two together, that's a union. That is an or statement. So the fact that we see both of these together means that we are taking them both together. We're taking the union. We have an or. Here, if this said and instead of or, then actually it wouldn't exist at all. Why? Let's imagine that we had an and statement. And is the overlap. X greater than 4, X less than or equal to -2 has no overlap. So there would be no solution to the and statement. Whereas the or statement would exist. It would just be the two joined together, the union of both. We saw that from a graph. We can clearly take the endpoints and whether it's a parenthesis or a square bracket and use our infinities to indicate both directions forever. Infinities always take parentheses. And if we have two of these intervals and we want to take the union, we use the union symbol. So we connect disjoint intervals with the union symbol. Today, we're going to work with solving inequalities, and then we're going to get our answer in inequality form. We're going to make sure we can put our answers on the number line and in interval notation. So all of that, taking the inequality answer, graphing it, putting it in interval notation, that's from the last time we were together. This time, we're going to use those just in writing our answer. But you need to know how to do that in order to get your answers the way that we want them. If you need a break, take a break. I'm not going anywhere. The beginning of our time together today, I reviewed that an and statement was the overlap. An or statement is taking both and combining them together. Let's go ahead and solve a compound inequality expressed as an or statement. So x minus 2 is less than or equal to 5, or 1/2 x is greater than 6. First step is going to be to solve each of these individually and then come back around and figure out what the or means for the problem. So over here, x minus 2 is less than or equal to 5. We can add 2 to both sides. We get x is less than or equal to 7. Over here, 1/2 x is greater than 6. We can multiply both sides by 2. Multiplying by the reciprocal gets rid of the fraction. 2 over 1 is the reciprocal of 1/2. That just leaves us with x is greater than 12. The or statement is going to take our two individual lines. If we had 6 and we had 12, 7 and 12 on the number line, less than or equal to 7 would be that. Greater than 12 would be that. Or is a union. That's both of them together. And what would this be in interval notation then? Well, we would have parenthesis negative infinity with an endpoint of 7, square bracket. We're joining it with this other interval. So remember, we use the union symbol. And the other one is going to be a parenthesis 12 to infinity. And that's going to be how we solve an or inequality. Let's do another. One-fourth y less than -1, or 3 plus y greater than or equal to 5. Let's solve them both and then come back and deal with the fact that or is a union. To get rid of multiplying by 1/4, we would multiply both sides by the reciprocal, 4. So y is less than -1 times 4 is -4. Over here, subtract 3 from both sides. Y is greater than or equal to 2. -4, +2, less than -4, greater than +2. The or statement is both of them together, so they both make it on to the final answer. Negative infinity to -4 with a parenthesis, union, square bracket 2 to infinity. Let's go ahead and do an and statement now. Yay. So much fun. Math is fun and exciting, and the problems are oh so delighting. Let's take a look at -1/4 t less than 2. And this is going to be an intersection, and 0.52 t greater than or equal to 1.3. Decimals and fractions, seriously? Okay. It's okay, we can handle it. Getting rid of dividing by -1/4, we can multiply both sides by the reciprocal. That would be multiplying both sides by -4. Excuse me. And once we actually do multiply both sides by negative, that's going to switch it from a less than to a greater than. 2 times -4 is -8. We're just left with the t on the left. Over here, 0.52 t greater than 1.3. We'll go ahead and divide both sides by 0.52. If you get your calculator, I know you don't want to do it by hand. I don't want to do it by hand either. So we're not going to. 1.3 divided by 0.52 equals exactly 2.5. That's what the book said it would be. I didn't trust it. I should have trusted it. So we have t is greater than or equal to 2.5, and t is greater than -8. So if we had -8, positive 2.5, greater than or equal to 2.5 would be that. Greater than -8 would be this. The intersection is the overlap. The overlap happens here. So just greater than or equal to 2.5. Now, sometimes we can see inequalities joined together and written in this form. We saw things like this last time we were together. It can be in this form before we solve them as well. Let's say we had 5 is less than -2x plus 7 is less than or equal to 11. This actually represents an and statement of these two different inequalities. And if you don't see the two different inequalities right now, this might help. There's the second one. If I get rid of the entire left side, then the middle becomes the new left and the right stays the right. -2x plus 7 less than or equal to 11. The other one's what happens when I get rid of the right. The middle becomes the new right. 5 is less than negative 2x plus 7. So this is an and statement that joins both of these. And so let's just play out the and then we'll come back and we'll play out the 3 part without changing anything. Seems like a good plan. If I subtract 7 from both sides, negative 2x is less than or equal to 4. Divide both sides by negative 2. X, switch this inequality greater than or equal to negative 2. Over here, subtract 7 from both sides. Negative 2 is less than negative 2x. Divide both sides by negative 2. Negative 2 divided by negative 2 is positive 1. Dividing by the negative means we switch the sign. And there's the x. This would be the same as x and 1. If we switch the sides, the x keeps the little point. Pac-Man's mouth opens towards the 1. So we have x is less than 1 and x is greater than or equal to negative 2. And statement is the overlap. So if we think of the number line, negative 2, positive 1, we would have less than 1. We would have greater than or equal to negative 2. And our answer would be the overlap. Our answer would be between negative 2 and 1 with a square bracket on the negative 2 and a parenthesis on the 1. That's the long way, splitting it up into 2, dealing with the and statement. There's a shortcut of sorts that's going to get us to the same answer. And it's just leaving it together. Instead of solving that one and then solving that one and using our strategy of whatever we do on one side, we do on the other, trying to get x on one side, let's get x in the middle. And whatever we do in the middle, we do on both of the other sides. So to get the x by itself, we got to get the negative 2x by itself. We got to get rid of plus 7. We do that with minus 7. Whatever we do in the middle, we have to do everywhere. All 3 sides, left, middle, right. That just leaves negative 2x in the middle. 11 minus 7 is 4. 5 minus 7 is negative 2. To get the x by itself, we have to get rid of multiplying by negative 2. So we divide by negative 2. Whatever we do in the middle, we do everywhere. Since we divided by negative 2, things switch. The less thans become greater thans. Less than or equal to becomes greater than or equal to. Negative 2 divided by negative 2 is positive 1. 4 divided by negative 2 is negative 2. Now, before I do anything else, I want to take a look at what happened here. When things are written like this, a three-part inequality, we use less thans. And because we use less than, because, for instance, 1 is less than 2 is less than 3, that works because the 1 is less than the 3. So it kind of has this transitive property. We want the least thing on the left, the greater thing on the right. -2 is less than 4. That's why we can use less than less than. 5 is less than 11. That's why we can use less than less than. But here, once we divide both sides by -2, there's a +1 on the left and a -2 on the right. Well, 1 is not less than -2. But guess what? The same time that that happened, the same time that became untrue, was the same time we divided everything by -2, which switches the inequality signs, which means everything's okay again. Because now, if we swap everything the way we do when we bring the signs with it, the -2 can come over here, the +1 can go over there, and the point stays with the -2. The big end stays with the x. Likewise over here, the big end goes with the 1. The point stays with the x. If you want to imagine, I took this answer, stuck a stake in it, and then spun it around. Everything flips. -2, point, big end, x, point, big end, 1. Everything flipped. It wasn't just changing the sign. Once we did that, it was greater than, and we don't write things like that. So we got to switch it. Got to stick a stake in it and flip it around. And look, now the or equal to is over here. The regular is over there. What would this be? It would be x between a -2 and a +1, with the or equal to being a square bracket on the left, the no or equal to being a parenthesis on the right. Same answer that we got. Maybe even easier because we didn't have to go through the number line to figure out how to write this as an interval. We can see our two endpoints. The smallest is -2, the largest is 1. Square bracket, no square bracket. Okay. Let's look at another. -16 is less than or equal to -3y minus 4 is less than 2. Whatever we do in the middle, we have to do to both sides. We want to get the y by itself, which means we need to get the -3y by itself. We need to get rid of the -4. We do that with +4. And we do it on all 3 parts. -16 plus 4 is -12. We just have our -3y in the middle. 2 plus 4 is 6. Next, divide all parts by -3. Negative 12 divided by negative 3 is positive 4. Since we divided by negative 3, we got to switch the inequality signs. Y in the middle. 6 divided by negative 3 is negative 2 there. We no longer have the least thing on the left with less thans. We want to switch everything around so we can have that. So copying it this way, we have our negative 2 first. The point goes towards the negative 2, big N towards the Y. And then the less than or equal to points at the Y with the big end having a 4. If you want to see it on the graph, you can. Between negative 2 and 4, no or equal to, yes or equal to, and we shade in the middle. In other words, negative 2 to 4, parenthesis on the left, square bracket on the right.